All right, hi everyone. My name's June. Welcome to my talk, Team-Based Matchmaking Without a Matchmaking Server. I am a sole trader slash owner slash I don't know what title to give myself at Redpoint Games. I've been in game dev for more than 10 years. I've lost track. And I've been working with Unreal Engine for the past 5 years. And I've been doing full-time plugin development since like mid-2020. So to give you a bit of overview of what I'm going to be talking about today, first of all, why did I build a team-based matchmaking system that doesn't need a matchmaking server? I'm going to talk about the general broad overview design elements of it. We're going to do a bit of an implementation deep dive into how it works. I'm going to be covering some edge cases and stability testing, and then if we have time for it, I will talk a little bit about future work and future plans. So to start off, why did I build this? So I was building a multiplayer team-based game in sort of early 2020. And because it was a prototype, I didn't really want to, pay any recurring fees for any like the cloud matchmaking. I didn't want to lock myself into something that, maybe a year down the track is not the best idea. And yeah, so I especially didn't want to pay money when it's like a prototype, whatever, it might not be released, whatever. And then I was sort of thinking, well, like Steam and EOS, they have free lobby APIs that you can kind of use to just like put people into games. Can we build team-based matchmaking on top of those? The answer, it might surprise you for this talk, is yes, you can. So I built a solution. Now, the prototype didn't end up going anywhere because plugins started making money, and I was like, okay, I'll go do plugins instead. But I did release a plugin on the marketplace. If you don't want to pay me money, or if you don't work in Unreal, this talk will cover the design and implementation so that you can re-implement it. So let's talk about the design. And in terms of what do we actually want, what are we starting with, and where do we want to get to? So first up, this is about like team-based matchmaking. If you're just trying to pair up two people and you don't have parties or anything, you can do it very simply on the top of the existing APIs. But what we want to do is we want to start with one or more players in a party. So you might have a solo player, you might have 3 people playing as friends. You'll have a desired team layout. So this can be anything. It can be a kind of 4v4, or it could be 3v3, or it can be like 20 teams of 4 if you want to try and do like battle royale or something. You're probably going to have some search parameters for maybe different types of game modes, and you've got the free generic lobby APIs that Steam or EOS will give you. What we want is we want to have filled game servers with teams allocated so that when everyone's in, it's like, cool, they're on these teams. We don't want any costs, and we don't want any matchmaking servers because we're indies with no money. We don't want any scaling or maintenance issues as the player base increases because we're indies with no time. And then we want it to be reliable as well. So let's have a look at what the free APIs from Steam EOS look like, what we've got to work with. So these, they have a list of lobbies. They're searchable, sortable by attributes. Players can create and join lobbies. You can set an overall limit for the number of people that can be in the lobby at any one time. And as I mentioned, you've got like custom attributes that you can set, and importantly, real-time notifications when people join or leave or the attributes change. All right. Some providers do have more features like chat messaging, but for portability, this is the feature set that I stuck with. So in terms of building a matchmaking algorithm without a central server, some of the hard problems we have to deal with is who gets to make decisions, right? If you think about we want to make a match, right? Like how do we decide who's deciding what's going to happen? How do we prevent clients from getting an advantage? And then because we're basically doing this all over client networks, people are on their ISPs, people's internet drops out all the time. We need to have good fault tolerance as well. And of course, the matchmaking still needs to be fast. There's no point implementing this if it takes half an hour to get a match. So what I'm going to do is we're going to walk through a bit of an example of kind of what the process is going to look like. We want to target a 4v4 team layout. We're going to have 4 parties in. We're going to have a solo player queuing. We're going to have a 3-person party queuing, and we're going to have 2 2-person parties queuing. and we're going to look at how we get to a single 8-player match. The answer on how we solve this is we basically merge lobbies together, and we continually merge lobbies together until we get to a result where the lobbies are full, or depending on the type of game, you might say, okay, well, it's acceptable to have, a 3v3 match, so we'll just eventually time out and just go to a 3v3 match. So from a high-level viewpoint, this is kind of what it looks like if you were to look at sort of an outside-in view. Each party, they queue with their own lobby, and then basically we iteratively merge the lobbies, merging all of the players together, keeping track of what teams they've been allocated, we kind of match until they're full. Each of the leaders of the lobbies is shown by the matching color, just to kind of give you a clarity on who's sort of in control of each of these lobbies. From the party leader's perspective, we're going to look at the blue user on this previous diagram here. What does it look like from their perspective? What are they seeing? What are they doing? So first up, at the very start, the blue users, they're going to search for lobbies. They're going to find this purple user's lobby, which has got two people in it, and they're going to say, cool, that actually looks pretty good. I can add those 2 people to my current team state because I've got two people. I'm the party leader and I've got one other person playing with me, so I want to have 2 more people on my team. They go and ask the purple user to merge, and the purple user says, yes, sure, that looks great to me. And so then the merge process happens, and the blue user at this point, they're still in charge of this lobby, they're still in charge of this matchmaking process. And then as they go to do their next search, the orange user comes in and asks them, hey, you look pretty good. Why don't you merge with me? And the blue user says, yeah, actually the orange lobby looks pretty good to merge in. So they notify all of the other members of their lobby that they're currently leading and says, we're going to go over there, we're going to join the orange lobby, and they merge. And then they basically just from that point on, they act like any other party client. They just follow exactly what the orange user wants to do. So in each lobby, wrong way. In each lobby, you've basically got hosts and clients, and this is important to note for who gets to make decisions, really. Party leaders and solo players, they always start as hosts, so they always create their own lobby, and they're the hosts of those lobbies. They run the matchmaking algorithm that we just described, and when, as I said before, when lobbies merge, they become a client and start following the new host. And clients, initially, it's just going to be party members who are not the party leader. They just do whatever the host of the lobby they're in tells them to do, and that can be either joining another lobby ID due to a merge, or it can be like joining a game server because matchmaking is finished. So how do we make things deterministic, right? How do we ensure that progress is made? Because I think you could imagine that if you've got lots and lots of hosts all running this logic at the same time, things can probably get out of control very quickly. You've got lots of hosts messaging each other, but we need to still make sure that things move forward. So to kind of introduce some stability into things, hosts will only consider other hosts, which we call candidates, that entered into matchmaking after them, right? And this basically prevents a situation where A looks at B and says, oh, I want B to merge into me, but at the same time, B is looking at A and say, oh, I want you to merge into me, and then who makes the decision? Who gets to choose, right? By making sure that hosts can only consider candidates after them, you never run into this problem because there is always one person that's going to be making the authoritative decision there. And we make sure that lobbies only accept incoming merge requests at certain points. So you can imagine that if you're in the middle of accepting another merge request, you don't want to accept another one as well because everything's going to get very confused. So we strictly define when incoming merge requests can be possibly accepted, and you need to make time for these acceptance points as well. So typically in my implementation, it's during the search, like when you're looking for other lobbies at that time, because usually it will take your back end, maybe a second or two or whatever to give you the results. During that process, you'll accept incoming merge requests. And to make sure that we basically make ourselves available if we're not making progress so that other people can ask us. We extend a delay before the search so that other people have more opportunities to pick us as candidates. So that's the basic design of it. We're going to look at the implementation now in terms of, okay, that was a high-level overview. This is going to be sort of more the detail. So the state that we need to track on the host, this is the party leader initially. Well, it will always basically be a party leader or solo player. They need to keep track of the current team state. So that's the status or the slot status. We use the term slots to mean players because the slot can either have a player in it or it can be empty. So the slot status of every team, which users are allocated to which slot. And you need to basically make this responsive to when players join or leave your lobby and when the merging process is happening. The hosts will actually have two matchmaking lobbies, and I'm going to talk about a little bit about why later. So they have the main matchmaking lobby the main matchmaking lobby, which is where the players join, and they have a notification lobby, which is where requests come in, because again, we don't have that. We're not using any chat APIs as part of this solution. A few other bits and pieces. So like we keep track of candidates that we asked, hey, come join our match, and they said no. And that's just so we don't repeatedly ask the same candidate over and over and over again and not make any progress. So then we sort of break things down to sort of a few stages of matchmaking. So we've got initial queuing, which is kind of setting things up. We then go into a cycle of like we're searching for candidates and we're merging candidates in. And we basically do that until we're either got, as I said before, until we've got like a full lobby or we sort of time out. And then the finalization stage is like, okay, I need to go find a game server. And depending on your game, that might be like a player-hosted listen server in Unreal, or it could be like searching for a dedicated server in the sessions list. There's a special phase called abandonment, which I'll get to later in the talk. So for the initial queuing, again, this is about getting solo players and parties into matchmaking. You might already have a lobby set up for the party, but you need to make a separate one for the match. It's important to keep these separate because you don't want to have, the people who are joining the match are joining your party. It'll get weird. So the match lobby is what will get merged, right, as we go through this process. You basically just tell all the party members to join the match lobby after it's made, and you wait for them to get in. If you're doing skill-based matchmaking, which I will touch on a little bit later, you also need to discover all the skill data for the players in your party and basically store that information, and you'll be surfacing that as an attribute as well. We also need a notification lobby because we don't have that chat API. This is how hosts will talk to each other during the merge process when they're saying, I want you to merge into my lobby. The reason we don't just use the main matchmaking lobby is we don't want a situation where, it's a 4v4 match, so your main matchmaking lobby has 8 maximum slots, and then, you have like 2 or 3 people send a merge request at the same time, and they can't get in because the match lobby is now full, right? Because that capacity is representing the capacity of the match, not any incoming notifications. You can do it other ways, in EOS you could try and do peer-to-peer notifications, but the second lobby sort of design is generic, it works on all platforms. After you've done the initial queuing phase, the host will have the following lobbies set up. So it's got the party lobby. You might not have one if you're just a solo player, or it depends on how you're handling parties. You've got the and if you do have parties, you're going to have an attribute in the party lobby saying, "Hey, join the match lobby." It's got the match lobby, which is where players will join and what will be merged. It has an attribute pointing to the notification lobby. This is so that when other hosts are searching for your matchmaking lobby, they can go, "Oh, I know which lobby I need to go actually message you in because it's a separate lobby." And the clients will just have the party lobby and the match lobby that they're currently a part of. So Now, everyone's in the match lobby and we want to start searching for the matches we want. So in the top right there, that's sort of going to represent our two-person party in the match lobby and the current allocation, the current slot allocations that we've put in. And you'll see we need to fill 6 slots. And so we're going to search for all the search candidates we can find that have up to 6 players in them. And I'm sure some of you have noticed that at least one of these is not going to work already. We only search for lobbies that are in a phase that would accept a merge request. So you will basically surface the current phase you're in as an attribute. And then that way, when you're searching, you're only going to search for lobbies that are actually available to accept merge requests. Once we've got our results, we then do some client-side filtering of the lobbies to those that are compatible. I don't know why the colours aren't showing up there. There's supposed to be a green tick next to the first two and a cross next to the last one. So we can't break or split teams during the merge, because this would split parties, right? You can see that there's no way to fit team 1 and 2 into our match because they're not going to fit with our team. And you have to remember that when we're doing our search, the underlying lobby APIs are not aware of the team layout. They don't have support for saying, oh, well, I need to fill like 2 slots on this team. They have no concept of teams. So you always have to sort of do this sort of filtering at the end. If you've got no candidates, basically just increase the weighting until searching again. And so this means that if you've just entered the queue, right, there's probably not going to be anyone ahead of you, right, in the queue. So when you're doing that searching and you're only searching for lobbies that are newer than you, you might not get any results. But there might be plenty of people that are already in the queue behind you, right? And so by waiting longer, up to some sort of sensible limit, you basically increase the chance that your lobby is, or your match lobby is going to be available in the search results when they search for candidates. And then they'll be able to send you a merge request. Otherwise, if you've got search results, you figure out the best candidate client side. So basically, you will score them, and you'll score them, how close will this candidate get you to a full match, right? If it's going to fill out all 6 remaining slots, then that's a pretty good candidate. If it's like 1 solo player, well, you'd probably prefer to take the lobby with six players. How well does the candidate skill level create a balanced match? Because you don't want to basically end up with a really unbalanced match, even if it does fill the lobby out. If you're storing things like player location, you can evaluate like how close is the average location of the other matches. And then once you've picked the candidate that you want to merge, you basically send a request to them. And then for the candidate, they will get the merge request. So you're in the searching phase, and you see another user join your notification lobby, and set an attribute saying, hey, I want you to merge with me, right? So you evaluate a few things. You need to check if it's safe to merge. Now, you may have advertised in the last, 2 seconds ago, you may have been saying it's safe, but you might have accepted another merge request in the meantime, because obviously this is all happening asynchronously. You're not going to have instantaneous data. So you might have to just simply reject the request because it's already too late. You've moved on to something else. If it is safe to accept the merge request, you basically check that the requester looks good to merge into. So you'll check that the skill level that they're advertising in their lobby matches what your Steam or EOS backend says, right? So you use this as a way of making sure that people aren't lying about their skill level. And you also make sure that you can actually join the target match lobby, right? So that you don't go, oh, sure, I'll merge into you, and you tell your clients to go there, and they're like, we can't join it. And everything would fall over, right? Yeah, so if it does look good, you accept the request, you tell everyone, including yourself, to join it. You clean up your existing lobbies, right, because you don't need your matchmaking or your notification lobby anymore, and you start acting as a client, just like all of your non-leader party members have already been doing. If it's not safe, or if the requester doesn't look good, you just basically say, no, I'm not going to join you, and you basically continue acting as if you hadn't received it, so you continue with searching. A tip for when you're receiving these merge requests is that if you have a particularly good lobby from the perspective of others, you might receive multiple merge requests. So you might have multiple people being like, oh wow, I really want you to merge with me. So a tip is sort of you get the first merge request, then you wait about a second to see if you get any better offers. And then you can pick the best one that you actually want to accept. Back on, back on the host that sent out the merge request. So if your candidate accepted, great. That means that they and all of the other people in their party are going to join yours. So you basically wait for them to join. You'll need to have a timeout for like, okay, if somebody's pulls the Ethernet plug out in the middle of matchmaking or something, right? You need to kind of choose what you want to do. You can either abandon and restart matchmaking, which I'll get into in a moment, or you can sort of just remove the timed out players from the list of expected players to join and sort of like go, okay, well they didn't join. That slot's now just going to be empty. I'll just keep searching for more, trying to continue to fill the match. If the match is full, once all the players have joined, congratulations, you've got a match and you can now go on to the finalization phase. Otherwise, you go back and you start searching for more candidates. If they rejected or they didn't respond in time, basically you add the candidate to the list of ignored lobbies so that you won't consider them next time, and then you go back and start searching again and try and find another candidate. Once you've got all of everyone in the lobby, or once your matchmaking is just taking too long and your game is, the way you've configured it is like, okay, it's acceptable to have partial matches. This is very straightforward. If you're doing player-hosted lobbies, player-hosted servers, you just have the host start a listen server and you tell everyone else, like, here's the IP address or the session ID to join. And then all the clients join the server. And if it's dedicated servers, then the host just searches for an available dedicated server that's going to match whatever constraints that you queued into, right? If you've got different dedicated servers for different maps or game modes. The host reserves a dedicated server, joins it, gets the address, passes the address onto the rest of the match. Usually during the reservation process, you'll also tell the dedicated server, like, hey, these are all the other users that I'm expecting to join, and that way only the people who are actually in the match can join it as well. So ideally, if everything went wonderful, you now have a multiplayer game with matchmaking and everyone's in teams and everything's fantastic. But what happens when things go wrong? And they will. Basically, this is what the abandonment phase is for. So this is for anything that you can't handle, right? Where you might have like a network disconnection or a player unexpectedly joins or API times out, right? Usually it's for like, I can't communicate with the other players in matchmaking that are involved in this to recover from the situation, or where the recovery process would be so complex that it's really not worth it. You just kind of want to throw everything away and start over. So the way abandonment works is if you encounter an unrecoverable error, you basically set an abandonment attribute on the lobby if you're the host, or on the lobby member data if you're a client. And if you ever see the abandonment attribute added to a lobby that you're involved in, you basically exit and you restart matchmaking. And this means that you clean up all your state, you go kick everyone back to like original parties, and then you requeue from the start. And it acts as like a poison pill, right? So like you see abandonment, you also abandon, and that way it gets everyone who's potentially involved and can still actually be communicated with out, and then you can restart matchmaking. Obviously though, this is expensive in terms of time. You don't really want to do it unless you absolutely have to. For things like API errors where it's like a temporary error and it's safe to retry the operation, like for example, like if the search request times out, you should just do like exponential back off instead, because you can recover from it. However, if you, we also use abandonment for cancellation, so you can think of a situation where the party is queued up and somebody unreadies. We use that to kind of like get that party out and kind of let all the other people who are still matchmaking, they kind of restart and go back through the process. You could do cancellation in a nicer way, but I haven't. It's totally up to you. You could have the cancelling party tell the host, oh, actually, we're cancelling, just fill us, just replace us in the match, but I haven't done that yet, so. Reliability and edge cases. So timeouts are your friend. Clients are notoriously unreliable. They can go offline or stop responding at any time. All the error handling code in the world is not going to save you if somebody's power goes out or they pull the Ethernet cable out or their ISP dies. So you have to have timeouts at every step of the process. So for example, merge requests when you're waiting for someone to respond, if they don't respond in time, whatever, you just go find someone else. If you're waiting for players to join or merge into your lobby, you have to handle the situation where the player doesn't join for all the reasons that I've talked about. Don't assume a request from somewhere has been acted on. You have to get acknowledgement, or you have to see the side effects of them actually accepting the request. Don't just kind of assume that it's going to happen. And when you're implementing this, think about the state of all the hosts at any given point in the algorithm. So you kind of have to, in your head, think about okay, what can this host look like when this host is in this situation, and how does that interact, and how do I make sure that I don't get into weird states or states I can't recover from. Try and make sure that you can't end up with two hosts thinking that the other is going to do something different than what is currently planned. So in terms of testing this algorithm and making sure that it all works, unit tests are good for the simple stuff, so the basic logical progression. But to really make sure it works, you really want to functionally test it against real lobby APIs, because you won't be able to really properly know all of the problems you're going to run into unless you test it against the real thing. So in my case, because I was building it for Unreal Engine, what I did was I basically spun up Unreal Engine clients in Docker containers, and then I had a script that continually launches new containers and queues new players in, and then I had a back end that basically monitored all of the tests to kind of see okay, is this person getting in? Are there any errors in the algorithm? And to make sure that it actually works even in the really bad situations, I also did a testing pass with what I call Chaos Kill. If you've heard of I think it's Chaos Monkey or something at Netflix or whatever, where they just randomly kill servers. It's a similar thing, right? It's to emulate what happens if a client disconnects at this really, really unfortunate time. Can everything recover properly? And that will help you tease out a lot of edge cases in your implementation. It helped find a lot of subtle bugs when doing this sort of testing. It does take a while to iterate through and fix all of the issues. You're probably looking at that 2 to 3 weeks and going, oh, that's a long time. But in most cases, what happens is because it takes time to do matchmaking, get enough statistical data, you basically run it overnight, come back the next morning, and you're like, what didn't work? And then you kind of go and look at it. I did a Technically Games lightning talk on this if you're interested in how all the testing framework stuff fits together, and it's also open source on the Redpoint website, which I'll probably link on Twitter or something after this. So we've talked about getting teams together, right? And that's actually the hardest part of this, is making sure that we can matchmake teams together, don't break parties, we don't have a matchmaking server, we can do it all as a distributed algorithm. Skill-based matchmaking on top is actually fairly trivial to do. I basically ported the open skill algorithm, which I think is written in Python or Node.js, and I ported that to C++. And then you basically store the skill data in an authoritative source like the Steam or the EOS Stats API. Like I said earlier, you just basically, for every search result you get back, you just fetch the skill data, you check that people aren't lying, and at least the open skill algorithm, that will give you the overall skill level of all the players that are currently in the lobby. So that's how you do your search for candidates that are near your skill level. And then you basically have your game servers update the player skill stat when matches are finished. This is probably only really going to work maybe if you have dedicated servers, because you need to have something authoritative updating the skill results. Future work. All right, so we're getting into the sections a bit speculative now because I haven't actually implemented this stuff yet. But these are roughly my design plans on how I think I might approach this. We're going really good on time, so we have plenty of time for questions at the end, I think. So geographic matchmaking, basically you want to prioritize players that are close together, idea being that you'll have lower latency. Broad-based bucketing on latitude and longitude in, excuse me, in like the lobby attributes, mainly because you probably, well, I'll get to that point in a moment. You basically run like multiple searches to deal with wraparound for players near the edges. So, for example, if someone's like right on like the international date line, that's what I was trying to get at, like where they kind of wrap around, you'll want to you might have to run multiple searches for people out near that edge. And then the client does more accurate filtering with like a non-bucketed latitude, longitude, to do actual, like have assigned distance value, which will give you the actual distance between 2 points on a sphere. You want to do this because like the lobby APIs probably that you're using probably can't really search on have assigned distance directly. So we kind of bucket the results first, and then we get the client-side filter to do a more accurate check when we're waiting. Because, I mean, you're going to be waiting against things like skill levels and other things. So this is not going to be like necessarily the highest priority for you anyway. When you're putting the latitude and longitude into the lobby attributes, obviously that information is available to anybody else who's searching, so you probably want to fuzz the numbers anyway a little bit, just for privacy reasons. I haven't implemented this on EOS yet, because EOS doesn't support multiple sort filters in the search results, so you can't, for example, search on skill and the latitude and longitude at the same time. And next up we have backfilling for dedicated servers. So if you're doing a game with dedicated servers, your dedicated servers can either be like available or they're reserved for a match, right? And so after matchmaking, hosts will find a dedicated server available for reservation and they'll reserve it, and then everyone joins and plays the game. That's better. Right. So, but what happens when someone leaves a dedicated server in the middle of a match and you need to backfill? The idea is you create a new status for dedicated servers, which is like a backfill needed. And you have the dedicated server in the session attributes indicate how many players are needed on each team. And then before you run your matchmaking searches, when you're on the client, you're searching for candidates. You search for dedicated servers that need a backfill, and you say, okay, well, and you say basically like, okay, there might be a dedicated server that needs like one person on team A and one person on team B. Can I make like a 1v1 match so that I can fill in, so I can backfill this server? And then once you backfill once you meet the backfill and the layout and skill requirements, so obviously you also check that you're not gonna, throw the skill balance of the server right out. And then you just message the server to see if they want to backfill, because again, they might be receiving multiple requests coming in saying, hey, I can backfill you, but they will obviously be receiving that sequentially, so they'll be like, oh, I've already chosen this other person, I don't actually need you anymore. And then if they don't need you anymore, like if they do and they say, cool, that's great, then you just basically join the dedicated server. But if they don't, then you just kind of like, okay, well, I've made 1v1 so far and my target is now 4v4 again. I just go back to searching and try and do matchmaking normally. I realized that I went very fast there. So thank you everyone for listening. And I will now take questions if anyone has any. Yes, down the back.
I'll just bring people up to the microphone.
Yep, that's. Yep. If people want to come line up at the microphone for questions.
How do you go about collecting aggregated statistics? Number of matches played, types of maps played, number of players,
that would probably be through whatever existing statistics stuff you're collecting, not so much in the matchmaking process, if that's what you're asking. Like if you just
I mean, does it need to be a Centralized service.
So you will still have like a backend like EOS or Steam that will usually be capable of storing that sort of statistical data, because we still use the EOS or Steam stats API for storing skill data, right? Because we still need that to be authoritative. It's mainly that the lobby and session APIs that you'll get in like Steam and EOS, they can't handle the team aspect, right? They don't know how to not break parties without this sort of algorithm being applied on top of them. Next question.
So with just when you do the matchmaking and you assess things like, the location, the skill level, various different attributes, do you apply like a multiplier to each one of them or whatever value to create like a point of like viability or something?
Yeah. So when you get, the way I do it in my implementation is I get all the results from the search based on the filters, and then I have a candidate evaluator that goes through and says, can this candidate actually fit in the team layout, right? If they can't fit in the team layout, then they're just unsuitable, they're not counted. Otherwise, you basically weight all of the different elements you want to have, and then that forms a score, and then you pick the candidate with the highest score.
Thank you.
Any thoughts regarding the host migration?
That's sort of a bit out of scope because this matchmaking process happens all prior to players joining the server. I have had people ask me before about like, how does this handle host migration in Unreal? It doesn't. Because basically that sort of thing is like, okay, everyone's on the server and now you need to do host migration because the host has gone away. Generally speaking, either you're going to have to find another way of doing host migration in Unreal or use dedicated servers instead of listen servers is usually the process.
Okay, hope you don't mind another question.
Sorry?
Hope you don't mind another
Yeah,
question.
go for it.
One
We've got
question.
plenty of time, so.
So what kind of scenario would you think the system is most suitable for, like a mobile or?
I would say it's probably suitable for like indie games and anything where you're not doing like super AAA stuff, right? Like if you're in a situation where you can afford to just throw money at matchmaking servers right straight out of the bat, then you probably should go do that. This is really sort of like, I'm an indie, I don't have a lot of money, I'm doing a prototype, it might not be ready for 2 years, I just need something. Then this is a good viable strategy for that.
Right. Thank you very much.
Thanks.
Just wondering what sort of security implications there are with the client sort of having quite a bit of trust with it.
Yeah. So as I mentioned, in terms of like the skill aspect, obviously you're using an authoritative server for like using the authoritative APIs for like checking to make sure the other clients aren't lying to you. In terms of clients misbehaving, at least in the algorithm that I've kind of outlined here, at best you can sort of misbehave. You can't really necessarily get an advantage, at least from what I've seen. In terms of clients misbehaving, my sort of recommendation is that you have clients report or self-report when other clients are not behaving as they expect, and then you would probably funnel that into some sort of system, and then you would say, okay, this person's been reported by a lot of other players. They're probably not behaving correctly in matchmaking, or they might have a tampered client or something of that nature, and then you'll just use like, in EOS there's the sanctions API, so you can just sanction that player and force them to partake in like a secondary matchmaking queue where the other players will ignore them, basically, something like that. Yeah.
That's good.
Excellent talk, by the way. Earlier you mentioned that with the matchmaking you sort of go through a bit of a like exponential back off where I guess servers and prospective clients what's the term, sort of ping each other for whether or not they're willing to join or be joined.
Yeah.
Has that process of sort of backing off resulted in issues that, especially around just concurrency and having them all synchronously or on a synchronized almost back off?
They don't tend to be synchronized anyway because the search API you're hitting is not going to respond in the same time to everybody, if that makes sense. And everyone's not queuing. No, everyone's not entering the queue at the exact same time or exact same period anyway. Right. So you get everyone stochastically offset. So you don't really usually see a lot of contention.
So there's not a whole lot of point in adding like a decorrelated back-off jitter or anything like that.
Not that I've seen in at least the testing I've done. Obviously, with the wherever it's gone. With this sort of testing, I mean, because of the hardware limitations, I can really only get up to, I think, 32 concurrent parties. So, like, that's not really going to test your 1,000-player scale. But at least, I do have customers using this, and I haven't had anybody sort of report issues in production of that type. So it gives me pretty high confidence it's not going to be a problem.
Excellent. Thank you.
Hey, is your game, when you actually kind of get to the actual gameplay, are you always running on a dedicated server?
It's up to you. So that was sort of the finalization phase.
So that's optional.
Yeah. Basically, once you've got the match, you can go wherever is appropriate for your game.
Couple follow-up questions on that. And so if you have peer-to-peer games where they're entirely peer-to-peer hosted, are you once you filled your lobby, do you then dynamically reassign the host to the person with the most upload bandwidth and stuff like that? Lowest latency?
You could. In the implementation I've done, it's just the first player it's just the host player of the lobby that actually completed matchmaking. But you can certainly do stuff like that. Yeah.
My other question was, so if you already have dedicated servers,
Yep.
And since they generally cost about 100 times more than matchmaking servers, what would be the point? What are the benefits, I guess?
Yeah, so initially when I implemented this, I actually only had support for listen servers. I didn't do dedicated servers initially. And then I had a lot more people than I expected saying, oh, what about dedicated server support? I'm like, okay, well, if people want dedicated servers. Generally speaking, when you are running dedicated servers, you're not having to do that much coordination between the dedicated servers, right?
Yep.
If you think about it, you can just kind of spin them up in your Kubernetes cluster or wherever. Whereas if you're trying to build a matchmaking server that actually scales as a centralized system, that can be quite complicated. I don't know if you've ever looked at like OpenMatch or something like that, but it is quite complicated in terms of making sure that it horizontally scales the matchmaking algorithm. So that would sort of be the benefit there.
Fair enough. Thanks.
Hey, thanks for the talk. I was just interested in what API you're using for setting packets and stuff. Is it just the Unreal stuff, or?
So you mean in terms of when you're actually connected to the game server?
Yeah.
When you're connected to the game server, for the EOS plugin that I write, we use the EOS peer-to-peer API for communications between clients and hosts. But that's kind of outside of what the matchmaking plugin is doing,
Okay, thanks.
Hey, thanks for the talk, really interesting. Curious how you handle end of match and then breaking, say, a group of 8 back into their original parties that they might have queued up in.
Yeah, so that's why we have the party and the match lobby separate, so that when the match is over, you just throw away the match lobby. Everyone's still in their party, so then you don't have that problem. Yep. Anything else? No? All right. Thank you very much, everyone.